as John mentioned, we are here to talk today about Omnibus OpenStack and cover some of the chef work that we've done for OpenStack as well. I thought, I'd kind of introduce myself a little bit. So in actually looking for images for this presentation, I typed in chef for OpenStack and I found this picture, and that's actually me talking on one of our Hangout meetings, walking down the street. So a little bit of background on me. I am based out of Boston, Massachusetts, originally from New York. I've been bouncing around the startup scene in Boston for about 15 years. And most of that work has actually been around C, C++ work, anything between kernel device drivers, massive petabyte scale storage solutions, massively scalable databases, but none of that actually qualifies me to speak anything to what we're talking about today. In 2012, I decided to take a leap and started working for a startup where I was one of about 6 infrastructure engineers building solutions for a very large Amazon presence. So we had upwards of about 1,800 instances. And within 2 months, I found that I was the only infrastructure engineer managing 1,800 instances. Despite that, I fell in love with the cloud. And even though I love Amazon, I decided to take a stab at OpenStack. And I've kind of been doing it ever since. So first, I guess let's do a show of hands. How many people in the room would consider themselves a developer? Okay. And ops? Okay. So somewhere in that interaction, there's DevOps, I guess. And how about, obviously, probably all Chef users. I'm not going to ask that question. But how about OpenStack users? Nice, nice. Growing. That looks like it's growing. And how about, has anyone played with Omnibus before? Cool. So again, looking for images on the internet, I decided to think about what makes complex systems. And I looked for some mechanical drawings, and I found this one, which seemed like it would make a good segue into what I'm going to talk about next, which is, if I were to take all these pieces and put them together, maybe with a hammer and a screwdriver, I would eventually end up with a sewing machine. But on a similar vein, if I were to take all of these pieces, this is actually an old architecture diagram for OpenStack, and try to put them all together, it'd probably end up something more like a yak shave. I don't know if anyone here has ever stood up, actually that would be a good show of hands, people who have actually stood up OpenStack before. Okay, and pain points, yes, no? Yes, so that is probably the largest gripe about standing up OpenStack, is that it's incredibly hard to stand up, and then once you actually do stand it up, managing it from an operational perspective actually becomes pretty difficult as well. So we now have this thing called Chef for OpenStack. This is a project that kind of came together thanks to some of the work that was done at Rackspace to start writing chef cookbooks for OpenStack. I think these are launched around the 2011 timeframe. And I guess it's about a year ago now, in the Portland Summit for OpenStack, the community decided to come together and take the Rackspace cookbooks and create more of a community. Not that Rackspace wasn't offering up their chef cookbooks as open source, but come together and have a definitive set of cookbooks that everyone could use. When the Rackspace cookbooks were out there, most people were actually either forking them and going off in their own direction. We felt it was a good idea to bring everybody back together. So some of the contributors, as you can see here, are AT&T, Chef, Dell, HP, HubSpot. That was the company that I was working at. Rackspace, SUSE, AT&T, and many, many more. And as I just mentioned, in 2013, after the Portland Summit, we basically came together and decided that we needed a place to put these things, and we decided to put them on StackForge. StackForge, for people who do not know about StackForge, StackForge is a repository for code that is related to OpenStack, but not particularly OpenStack core. So this was a perfect place for us to put it. And the benefits of using StackForge is that we get very nice things like being able to use, we could do this anyway, Launchpad, but more importantly, the entire OpenStack CI system. So I was taking a look, and I actually didn't know these numbers, and I found some of these interesting. We have 10 service cookbooks, and what I mean by that is what we've done is we've taken all of the different services, so Nova, Glance, Keystone, any of the Cinder, any of the core services, and we've built them into cookbooks. So they exist as their own single cookbooks. You can mix and match them in any way that you would like to do so. Some of the ones that we don't have yet, though, are like the Troves, the Ice Houses, and those should be coming. We do also have 3 reference cookbooks. The 3 reference cookbooks are primarily around two primary aspects are to set up messaging. So with OpenStack, you require some message bus, whether that be Cupid or Rabbit. Some people use Xero. We do not support Xero, but this is a reference cookbook. We don't intend to tell you how to do this. It's kind of up to you, but we give you an example of how you can. The other one would be databases. So we support right now MySQL, and we actually support MySQL, Postgres, and DB2. However, this cookbook does not show you an example of using DB2. And the final one is actually it's actually just a wrapper cookbook that has a number of different roles where it shows you how you can kind of compose all the cookbooks into a custom setup that you like. So, as I mentioned before, these are highly composable. You can use them however you'd like. With these cookbooks come a number of lightweight resource providers. So we have things like creating Keystone users or uploading Glance images. And these are actually, we're always adding new ones. So if you have something and you'd like to see it in there, please feel free to contribute it. And again, like I mentioned before, we have the continuous integration pipeline that's offered to us through StackForge. So because we are kind of always in a fast follow mode with the OpenStack community, so right now we've actually just landed Icehouse, I think as of this morning. And for those of you who don't know, the versions go in alphabetical order, so Grizzly, Havana, and now Icehouse. We're kind of always in a fast follow mode, but we have already forked for Icehouse, and there are folks at IBM who are already starting to work on Icehouse support for the Chef cookbooks. Primarily, the operating systems that we're using, or that we're supporting rather, are Ubuntu's RHEL, and we actually have some folks that are supporting SLES as well. And I think we also landed Trusty either today or it's about to land. So Ubuntu 14.04, and I'm sure that we will be moving to newer releases of operating systems as they get released. As I mentioned before, we have messaging support for Rabbit and Cupid, MySQL DB2 and Postgres. I always use the air quotes for hypervisors because you'll notice that some of these are actually not hypervisors, like LXC. So KVM, LXC, QEMU, ESX, and Hyper-V. And Neutron and Nova networking. So I think most of the solid stuff is around Nova networking because it kind of just works. Anyone who's ever used OpenStack knows that Neutron can be quite a beast. It tries to provide all the flexibility of SDN for any kind of use case that you could possibly want. And for block storage, LVM, standard LVM for Cinder, as well as NetApp. There are also a number of cookbooks out there, I should mention, that while they're not on StackForge, they are related. So for instance, I have one that is used for Nova Bare Metal hypervisor again. But because Nova Bare Metal is going to be going away being replaced with Ironic, it's not actually been added to the StackForge stuff. So I have to give like a huge shout of thanks to the people who have made this happen. There's a number of people in the room, both from Rackspace, Chef. It's been awesome. And I was looking again for images on the internet, and I knew I had this one out there, but I asked Nathan, I modified this one a little bit. So thank you for stirring up delight. That said, Chef to stand up OpenStack is awesome. I've been very pleased with the progress that we've made over the last year in doing that, but there's still a problem with setting up OpenStack, and this is a problem that's pretty generic to the OpenStack community. In fact, there was recently an operator summit in San Jose in I think it was the early March, and one of the largest gripes that everyone had was that everyone in that room, we're talking about large scale operators like the eBays, the Yahoos, and every single one of them pretty much had been building their own packages. And this seems like a problem. So the problem is that you want to be able to control your own destiny. If you're dealing with distro packages, like, if I'm waiting for Ubuntu to land Icehouse, that kind of excludes me from doing a continuous deployment scenario. I would have to either wait for those packages, or I could go online, go to Launchpad, get their source, and build my own packages. But there's all kinds of dependencies that become problematic when you do something like that. So, and if you're not controlling your own destiny, you obviously are not controlling your own product map. And again, right around this time last year, in fact, this is my first Chef event. I did not make it last year, but Matt Ray and I had kind of been noodling over this kind of idea prior to the ChefConf last year, and I believe he had a Birds of a Feather session, and it was brought up that someone should do this, and I took it upon myself to build a project that's called Omnibus OpenStack. And the idea here is that we're taking all of the components that you would need for OpenStack and building them into a single package. So this package is huge, as you can imagine, but just like Chef or now Chef DK, you get a single package that you can manage all of your dependencies underneath. So how does it work? Basically, all that I'm doing with Omnibus OpenStack is I'm wrapping the Omnibus tooling that's already been built for Chef. They've done a fantastic job, especially with 3.0. I have to thank them. It's much, much faster than it had been. But there's nothing really special going on here. I'm just acting as another executable that wraps around Omnibus. The one thing that's a little bit different about the way that I do things is, so if you're familiar with how Omnibus is packaged, typically what you're going to have is a GitHub repository that has all of your configs. So you would basically outline that here's my project. In the case of Chef, the project is called Chef. And then I have software dependencies that get built into that Omnibus package. So in the case of the Chef package, that is a preparation configuration that basically prepares the system for building the Omnibus package, Chef, which the only thing that it does is build Chef, and then what's called the version manifest. The version manifest just basically tells that package, hey, this is what you have inside it. The way that I'm doing this a little bit differently is that I want to make this very generic. So the OpenStack community is entirely Python based, and for good or ill, sometimes people see Ruby and they're like, I'm not touching that with a 10-foot pole. So I could have written this descriptive language in the standard Ruby DSLs or built my own DSL, but I decided on YAML. And what this allows anyone to do, even from the OpenStack / Python developers, is to build their own package as well without having to think about how Omnibus works or know any of the details of the innards of how it works. So just like Omnibus for Chef, it builds all the system level dependencies. So we're talking about the OpenSSLs, the Pythons, anything that I would need to actually run these particular services or clients is going to end up in this package. And for those of you who are familiar with virtual envs or the Python community, so a virtual env is how I package all of these particular projects. So you tell me which projects you want to build, whether that be the Glance, the Novas, the Keystones. I will create a virtual env and I will install that project to its own virtual env. The advantage here is that by building into if you were to deploy these packages through like pip install, you could, and you were doing that at the system level, you could potentially pollute the entire the Python syspath space. So, and you might encounter projects like, I'm installing the Keystone service as well as a Nova service on the same box. They both call for a certain dependency, which happen to want different versions, and now you're stuck in this scenario like, okay, how do I handle this particular problem? By building into a virtual env, we don't have to worry about that. So we're entirely isolated to our own both virtual env sandbox as well as our Omnibus sandbox. So one of the things that you are going to need if you ever want to use Omnibus OpenStack is a build environment. So I have built a project. So what you'll see in the next couple slides is there's a whole ton of projects around how this becomes possible. I think there's probably like 5 separate Git repos that handle this. But the build support, basically the idea of this repo is essentially to provide you a way to basically submit a YAML file, and out the other end comes a package. right now, just like with normal Omnibus deliverables, there's a Vagrant builder. I do it a little bit differently than they do. I use an inline shell provisioner, and I've also recently added OpenStack Heat support. So for those of you who are not familiar with Heat, Heat is the kind of CloudFormation equivalent for OpenStack. And just to provide you an example of how you would configure this, so if you see on this first area where I say Keystone and versions, right now I'm calling for stable Havana, and I'm going to, in this case, I'm using the standard GitHub repositories for Keystone. This could be, but you could choose any SHA ref, any kind of Git ref that you'd want to use, and you could also point it at your own particular Git repo. So if you decided, hey, Nova doesn't quite do this the way that I want it to do, I'm going to create a patch. I'm going to fork Nova. I'm going to apply my own patch, and I want to be able to build that into a package. Now you have the capability to do that. That said, also, if anyone's ever committed code to OpenStack, the acceptance time for some patches can take quite a long time. So for someone who's running this at scale, like we are, we can't really wait for the community. Even we will submit our patches upstream, but we can't wait for the community to actually get a necessary fix out. It's the same way if you were to notice that in Havana there was a specific security issue that you wanted to deal with, or some bug that got backported. Again, you don't have to wait for Ubuntu or any of the distros to decide to package that up. You can go package it yourself. And again, so this file is also telling Omnibus exactly what to build. In this case, I'm only building Keystone Glance, Keystone Client, and Glance Client, but you can make it as long or as short as you want. So the basic premise here for this is, now I've kind of backtracked a little bit, so that's how we build it. And if you just want to say, I don't care about Vagrant builds, I don't care about Heat builds, I just want to try it on my own box, it's very simple. So if anyone's familiar with the Rubyland or Bundler, first you're going to do a bundle install. I didn't show that because the output would be quite long. But then after that, I'm just showing the help command, and the last line there that's kind of cut off is the only thing you're going to have to actually run to make this happen. So bundle exec omnibus OpenStack build, and -m is for a manifest file, and that manifest file is the file that we had just seen. I also provide other options like install path. Maybe you don't want to set it up in opt OpenStack. Maybe you want to install it to opt my company's name -1, version 1234. You're free to choose whatever you'd like. And the cache stir is there just to kind of pass through to Omnibus so that if you do decide that, hey, I did a build, and at some point I want to change something and then rebuild, you can use the same cache, and we will only rebuild the pieces that you actually need to rebuild. Because builds actually take quite a long time. I think the best I've ever seen I'm actually building a quite large Omnibus package. It's around 300 megs, but it's pretty much supporting all of the services that you would, all the core services for sure that you'd see out there today, and it takes about an hour. So out the bottom, hopefully you have some nice large package that gets spit out. And now you have this package, and what do I do with it? So if you guys have ever installed Chef Server, you'll know that you can install the package, but then you're going to basically reconfigure it to be able to leverage that sandbox to run the Chef services. And somewhat in an analogous way, I'm doing the same thing. So I'm providing you would, in my case, what I've been doing is I take that package, I drop it onto one of my apt repositories, and then I have a wrapper cookbook that will sit there and actually set up all of these services for you. The idea here is that this cookbook has no StackForge dependencies, so I didn't want to get in the way of StackForge work in the great work that those guys are doing. But there's a way for me to kind of sit on top, and instead of them doing the work, I'm doing some of the work up front. For instance, where they would go off and install a Yum package for Nova, I'm basically saying, don't do that. I've already done it. Right now, I'm only really supporting Ubuntu, so I'm using Upstart and Update alternatives to basically tell the system basically give the system an idea of where these things live. But there's no reason why we couldn't do this just as easily for any other operating system, just that this is my use case. So if you have code, feel free to contribute it. And again, here I'm showing the Vagrant provisioner, how I would actually use this. So I've created another Git repo. This Git repo is basically another reference implementation of how you could make use of these particular cookbooks to make this all happen for you. And what we can see here is the first thing I'm doing is probably pretty standard for anybody using Ubuntu, is running the apt default recipe. This second recipe here is the Omnibus OpenStack reference recipe. And what I'm doing there is I'm doing the things that any reference implementation would have to do. So setting up the databases, setting up database users. I think there's a couple of packages that I install, such as like Build Essentials and Git and stuff like that. I'm not really sure I even need all those, but they're there anyway. And then this OpenStack Omnibus default recipe, this is the part that's doing all the work. It's saying, okay, I'm gonna walk through, you've told me which services that you wanna run, and that's actually down here where you see this Omnibus enabled services line. In this line, I'm basically saying, I want all of the identity services. In fact, identity services is only one, it's Keystone. But for the case of Glance, there's Glance API and Glance Registry. I've told it I want all of the Keystone services, but in this case, I only want the Glance API service to be running on this box. And that's all being handled by that third line in the run list, the add recipe OpenStack Omnibus default. And based upon attributes that you set there, it'll make different decisions on how it sets things up, whether it uses init.d or upstart or whatnot. And then the two lines below that are StackForge cookbooks. These are cookbooks that live in StackForge now. These are all cookbooks that you can use already, and they're doing all the setting up of things like, okay, what does the Keystone configuration look like? What does the Glance configuration look like? Do I need to restart services when I drop those templates? Stuff like that. So I'm not doing any of that work. I'm leveraging all of the StackForge work that already does that, and I'm just sitting on top. And so I wrote that cookbook last night, probably in an hour, because I realized that I didn't have a really good reference for something like this, and there probably should be one. And I did that on the conference Wi-Fi, so sorry about that. And you can also see why it took so long, 975 seconds to pull a 300 meg package. But what this is showing is that at the end of the run, we have two services that are up and running. And those are, as I mentioned before, Keystone and Glance API. So one thing I didn't mention is this actually amazed me as well. So I looked at the StackForge StackForge cookbooks just to see how much code was in there. And it turns out that there's almost 25,000 lines of code. I'm not talking about templates, just straight code. And this project, for the most part, I've been the only contributor. I think I have one pull request from someone else, but there's 2,000 lines of code there. That said, things are not perfect. So as I mentioned before, we need extended platform support. Ubuntu is probably not going to cut it for everybody, so I'm happy to work on other platforms. I just have not had time. If you have a need, if you have a use case, by all means, I will accept the pull request. Better documentation. This is because there are so many repos kind of being pulled together here. I want better documentation, and this is something that I'm working on right now. And most of all, testing. I have no tests right now. So this was kind of a proof of concept for me first. I needed to get to a point where I understood that this is going to work. And at this point, I'm going to be adding tests back in. I should mention, though, that there are tons of tests around the StackForge cookbooks. So why would I want to do this, right? So first, as we've seen even in the Chef server case, right? Service isolation. I want to be able to deploy a service across multiple platforms or distros and not have to worry about system level dependencies. Custom versioning. With custom versioning, I can basically say, I don't have to wait for, as I mentioned before, the distro packages. I don't have to wait for the Ubuntus. I can say, this is my point in time that I understand works well together. I'm going to take all these bits, I'm going to put them all together, and I'm going to call it my version. Maybe that be 1.0 or 2.0. And that gives you some kind of insulation from upstream. You don't have to worry about the Ubuntu changing something or Red Hat changing something. You're now constrained to what you know. continuous deployment enablement. It's right now for most people using, well, I can't imagine any use case where if you're using distro packages, you can do CD for OpenStack, unless you're building some kind of custom deployment mechanism like we're talking about here. I think people are doing it, but it probably amounts to things like building up tar files that contain all the bits and shipping them out. So why not just use packages? Again, cross-platform. And it's configuration management agnostic. Even though we're here at ChefConf, there's no reason why you couldn't use it with an Ansible, a Puppet, SaltStack, whatever. This is completely CM agnostic. So, possible downsides. One of the possible downsides is installation from upstream. So, as we saw last week with Heartbleed, if you're not paying attention to stuff like that, you probably would want to be paying attention to stuff like that. So in the case of Omnibus, you'd have to realign your OpenSSL software configs and rebuild. Another problem that we've run into, especially on two projects. So one is Horizon. Horizon is typically deployed with Apache or Nginx. I have not tried Nginx yet to deploy Horizon with the StackForge cookbooks, but at least for Apache has its because it's running in a different process space. It is basically starting up with certain environment variables that need to be passed to it. So luckily there's a configuration file called mvars for Apache where you can set LD library path, which is something that we would need here because we're essentially changing the library paths and the bin and the standard pathing. But that file also contains other environment variables, so that can be a little bit hacky to deal with. If that changes, you might not capture what's being done upstream. The other one is Nova Compute. Nova Compute has a dependency on libvirt. Oh, sorry. Sorry, can you repeat that? Yeah, so we're setting the LD library paths because we're building things like Python, right? So our Python interpreter is actually living inside the Omnibus package.
Yeah, so in your Python build definition file, you've got some GCC flags with RPath that point to the embedded lib here. If you copy that into all of your build definitions, you'll magically find your lib Python.
Okay, I was not aware of that.
You sprinkle that everywhere in all of your other all of your lower dependencies that need lib Python.
Okay, yeah. I'd be happy to look at that because that's kind of a real pain point. So the question was, why am I changing my LD library path? And
I just went through this.
Okay, yeah, awesome. Pull request accepted. The other one that we were talking about is libvirt. So Nova Compute and libvirt. So Nova Compute has pretty tight dependency, obviously, on libvirt, and libvirt has pretty tight dependencies on the kernel that you're running. And most people are a little bit wary about trying to track libvirt because it's a bit of a beast. So that still needs to be resolved, and not really sure where that will land. I think maybe I'll provide options for you actually reaching outside of the sandbox to talk to the standard system libvirt. In fact, the libvirt on Ubuntu is pretty old. And again, you need to keep current. You need to know what's in that package. But if you're deploying this stuff at scale, you probably have a team that's already doing that to some degree, I would hope. So lessons learned. Adhere to Omnibus principles. That was the first thing. So when I first went down this path, I had this idea that I had a lot of projects that were going to use common dependencies. So like perhaps Nova would share dependencies with Keystone, and why not just take all those dependencies and put them in an Omnibus common package and then build each of the pieces like Nova or Keystone into its own package by itself. Don't do that. Just build one big package. The other thing is don't fork Omnibus. I ended up forking Omnibus to support that manifest, and I ended up in a world of hurt when people like Seth and Adam plowed ahead with the changes that they wanted to make and spent considerable time refactoring. So I would only fork as a last resort if you plan to do something like this. That said, the work that they did is awesome, and now I am not forked. I am on 3.0 for Omnibus. The other thing is, one best practice I think for Omnibus, as I alluded to earlier, is ship all the bits everywhere. Don't think of Omnibus as this is a piece of the service that I need to build into an Omnibus package. Build your entire system and ship it everywhere. And then with Chef, turn on or off those services where you want them to be. So where next? Even though we're building Omnibus packages for this Python project, one of the problems with Python and the way that OpenStack, well, it's not a problem with Python, but more the way that OpenStack works is there's no tight dependencies. So it'll say something like, I want Cliff greater than or equal to 1.0. Well, when the Python community moves on, unless you're managing your own pip repositories or PyPy repositories, your artifacts will move unexpectedly. So I want to get locked pip dependencies into the project itself. Additional build options. I don't even know what I meant by that. Additional build options. So I talked about Vagrant and Heat support. There may be people who don't have Heat and don't want to use Vagrant. We could do the same thing with standard either a Python script or a Bash script to do the same thing. It would be super handy if we had nightly or blessed builds so that people can just kind of consume where they see fit. And I would think that those builds would be something that would be massive and encompass all of the projects that we kind of know about. I've been playing with this a bit, and I've actually gotten it to work where I actually take the Omnibus packages and drop them into a Docker container and run the services from the container itself. So it's like, it's no longer turtles all the way down, it's containers all the way down. And auto discovery of services. So one of the things from the StackForge cookbooks is that they're very nicely laid out into, identity, recipe. Let's say identity is a bad one because there's only one. But if I was doing Glance, like I mentioned before, it could be Glance, recipes, API. So it would be nice if my cookbook, the wrapper cookbook, could look into see what's in the run list and say, I don't even care if you tell me what I'm running. I can see in the run list that you already want Glance API. So where do we go from here? So if you wanted to try this, or you want to try the StackForge cookbooks, we are always hanging out on Freenode on OpenStack Chef. There is a relatively active mailing list, but someone will always answer your questions on the mailing list. It doesn't get a lot of usage, but it does to some degree. And then we also have a weekly hangout at 11 a.m. Eastern time on Mondays. And the link for that is always distributed both to the mailing list as well as to the IRC room. So aside for the references, this deck is on GitHub. And then all of these links are also on GitHub. If you want to reference this for any reason, or you want to contribute code, please do. And you can reach that all right here. And that's all I have. Yeah, sure. Yeah, that would be good to leave up, huh? Matt? What's that? Are you using it? Oh, very good question. I am not using it in production yet. The question was, are we using it in production? However, there happens to be a very large telecom in Asia that is using this in production, unbeknownst to me until I got here. So apparently they don't care about tests, but we'll get there.
Ship it.
I'm sorry, it's very hard to see with the lights, but go ahead.
So in using this, you don't actually manage the OpenStack environment with your normal Chef server, correct?
No, you could. I mean, you probably would, in fact. So the only thing we're doing here, so again, we're only laying down bits. So just like you would have any, I'm going to move to the side because I cannot see you at all. So the only thing we're doing here is laying down bits. And the StackForge cookbooks are sitting on top of it. So those StackForge cookbooks, whether you decide Chef Solo is your way or Chef Server, that's completely Chef, right? So the point of Omnibus is literally just to lay down bits.
Just a package.
Just a package. Just like you could potentially, there probably is this, like write a Chef cookbook to lay down Chef, right?
Which one? Chef server.
Well, Chef Server cookbook, yeah. I always do the, pipe to sudo bash. Anybody else? Jesse.
Thoughts on the libvirt problem?
What are my thoughts on the libvirt problem? I think so. Yeah, I think this is a hard one. So this was actually brought up by one of Jesse's colleagues, and I had not really explored that path yet. And when I finally did decide to explore that path, again, it was just problematic the whole way through. So I had. If you look, there's actually some software to start building libvirt, and I pulled it out since because it requires an enormous amount of dependencies, and again, it has that tight binding to what the kernel supports. So my thoughts right now are to make that optional. So again, like I said, perhaps provide to virtualenv, you can basically say, hey, you can use system Python dependencies. And I think I'll make that an option that you can, if you plan to use Nova Compute, in this case, reach out to the system level Python dependencies. But yeah, you can't omnibus the kernel, not yet at least. Yeah, I lost my train of, I was going to say something else, but I lost my train of thought. Yeah. But, again, computes are cheap, right? So like all the logic is in the data plane, which is not Nova Compute. In the control plane, which is not Nova Compute. Perhaps we even run Nova Compute in its own container and talk to libvirt that way and isolate it that way. So in fact, that's something that I'm really interested in doing. Anybody? Okay. Thank you very much.